Yes, please go ahead.
Hello, I'm Anamika Gautam, working in bird community pattern along urbanization gradient. Today, I'll be presenting some of the key findings from my recent field survey, especially focusing on species like plum-headed parakeet and rose-ringed parakeet. I would like to introduce these birds as excellent bioindicator of habitat quality and human disturbance. As urbanization continues to transform the landscape, it become very important to the understand how these birds respond to urban rural gradient uh, for uh, for biodiversity conservation and urban planning. Therefore, I aim to assess the influence of local habitat and landscape factor. Uh, what did I do? Did I stop my presentation?
No, it's still running.
Okay.
You're in the objectives.
I think it's gone from my.
Put the next one. Let's see.
I cannot see my
If you
slide.
push the Windows button on your keyboard, it might.
I got it. I got it. Thanks. So my aims are to assess the influence of local habitat and landscape factor for the density of these species and to compare the density along urban, semi-urban, rural landscape and over the season. My null hypothesis is that there is no significant difference in the density across the gradient, and my alternative hypothesis is that there should be higher density in rural area and lower density in urban, as there is reduced fruit and floral resources in urban landscapes. My study area is in northern part of India. Here, this gray part is my study area, which lies in Indo-Gangetic Plain. This is actually the river Ganges, which makes it perfect area for agriculture and different type of habitat. So to convert my to divide the study area into a different layer of urbanization gradient, I collected raster data from global human settlement layer and the data from divided it from 7 layers to 3 type of gradient layer, and 1 by 1 kilometer of grid was overlaid to the study area, and stratified random sampling was followed to select the point count station over the study area to have a proportional number of sites across all the gradient. And then bird survey was followed as 100-meter fixed radius survey for 10 minutes, and it was surveyed in summer in March to May 24 and in winter November to January 25, and 3 replicates were done in each season. The survey was conducted by following the distance sampling assumption. In this, the distance sampling assumption assumes that the observation at zero distance are perfect, and as the distance increases, the detectability of the object decreases. And in distance sampling assumption, it gives 4 different kind of detection function: half normal, hazard, and half normal rate, hazard rate, exponential, and uniform. As it is shown in the graph, the first one, it shows half normal detection rate of half normal rate of detection, and the second is hazard rate. So in hazard rate, the probability of detection drops suddenly, whereas in half normal, it gradually declines, making it half of the normal shape. We collected almost 22 predictor variable from the field survey from 5 different uh, group. As first in vegetation group, we collected grass cover, canopy cover, shrub cover, and tree count. Similarly, from different group, we collected the we recorded the predictor variable from the survey. and all the predictor variables as part of my data analysis were normalized, because each predictor were in different unit. So the normalization was done using scale function, followed by Pearson correlation to avoid the collinearity, and then followed by NMDS analysis with Bray-Curtis matrix, then followed by hierarchical distance modeling. So in the models were built in using unmarked package and dist AMP function hierarchically. Like first we built the models uh, from the from the variables using each group. Then the predicted density was tested using Kruskal-Wallis test, and then it was also mapped using ArcGIS over the study area. All the analysis was done in R. This is the R package detail for each analysis, for data transformation, for Pearson correlation, the core plot and current package. Similarly, these package are used. In result, we found that these are the Pearson correlation plot for summer and winter season, and the correlation cutoff was kept at 0.5, and any variable which were highly correlated more than 0.5 were removed. This is ordination plot showing 185 study point sites with stress value 0.05, showing excellent representation of the dissimilarity in the study area. And the habitat variables such as multi-story buildings and thatched roof house and tree counts and distance to water bodies were very strongly associated with a different landscape gradient, where in rural area vegetation and tree count was highly associated. In urban area, the factors like multi-story building and garbage dump sites were associated, whereas the semi-urban area had a shared characteristic of the two other gradients. We found that the detectability was affected by temperature for plum-headed parakeet in winter season, whereas in summer season there was no factor which was affecting the detectability. In case of rose-ringed parakeet, in summer, air quality index was affecting the detectability. It was positively associated, whereas in winter, it was hazard rate of detection, and the detectability factors were temperature and AQI. In case of density, the factors that were associated or influencing the density of these species were, in case of parakeet, area of agricultural land was negatively associated with the predicted density, and distance to road, distance from the point count actually to the road was positively associated for the predicted density of plum-headed parakeet. And in rose-ringed parakeet, canopy cover, distance to road, and thatched roof were the significant factor which were associated in summer season. And in winter season, for plum-headed parakeet, the canopy cover was positively associated, whereas thatched roof was negatively associated. In rose-ring parakeet, single-story buildings were positively associated for predicted density. These are the maps showing the bubble map for predicted density mapped across the sites, survey sites for summer season and winter season. Here we can clearly see that the density in summer season were lower, whereas in density in winter season across some of the sites were higher in both the species. So for a plum-headed parakeet, in both the season we can see that the density was higher in urban area as compared to the two other gradient. And In winter season, we see higher density as compared to summer season. Same pattern we found for the rose-ringed parakeet, where the density was higher in urban in both the seasons, summer as well as winter. And in when we tested the Crystal Valley's test for season, it was the same pattern as we found in plum-headed parakeet, that it was higher in winter, the density was higher in winter, whereas it is lower in summer. So in winter, approximately it was double than the summer. So we conclude that the higher density of rose-ringed parakeet in our study was much higher than one of the study conducted in London. This was probably because the native versus introduced dynamics of the species, as these rose-ringed parakeet species are native to South Asia and Africa, whereas it is introduced in the European and other part of the world. And we also conclude that in plum-headed parakeet, in our study, the density was much higher than, probably because of the difference in habitat as that study was conducted in sal forest, and in our case it was in higher resources in urban area as abundant food and nesting.
Hello, Anamika. I think we lost her connection.
I think she
Please.
had frozen, yes.
Yes. So yeah, she lost. Hello, Anamika, are you there? No.
Hello. Hello. Am I
We
audible?
lost your. Yeah, we lost your connection in the very ending.
Am I audible now?
I can
hello?
hear you. It's okay.
My
You have
presentation is running.
your time is over. You're almost finishing.
Okay.
In the conclusion.
Yeah.
Well,
Yeah.
maybe we
So-
can share the conclusion in the breakout room.